For our machine learning for Virginia project, we've chosen to predict stock market prices using a recurrent neural network. Specifically, we'll be using the long, short-term memory model.
The stock market plays a big role in influencing consumer confidence regarding the state of the economy. In turn, companies and stakeholders often seek advice on how to make informed stock purchases. However, as the market becomes increasingly complex, it becomes hard to make smart, data-driven decisions. We wanted to explore predicting stock market prices by leveraging machine learning to address this situation.
Especially with recent recession, the collapse of the Silicon Valley Bank, and the massive tech layoffs, this research is now even more important. In many sectors, the stock market serves as a measure of economic stability and reflects the overall health of industries and businesses. By accurately predicting stock market prices, we can prepare stakeholders for the economy's future. Our accurate predictions can help companies anticipate market trends, adjust production levels, and strategically plan for the future. The benefits can even extend to the residents of Virginia.
We use 5 datasets from companies that have a strong presence in Virginia. These companies are primarily based in Northern Virginia, where they have strong influence on lawmakers in DC. While being primarily in the technology sector, we wanted to select companies that had strong economic impacts in all industries to demonstrate how versatile the results can be. In addition, these companies are known for hiring UVA students prior to the hiring freeze and layoffs. Another interest Virginia has in this project is leveraging the results to help students monitor the economy and track when hiring periods may turn back in their favor. These results can be used in similar applications, especially to the government contracting sector, which is prevalent in Northern Virginia.
In order to execute our project, here are the steps we took. First, we gathered our data sets. Second, established a baseline for stock predictions. Third, leveraged long short-term memory model. Fourth, fine-tuned the long short-term memory model. And lastly, we analyzed our results.
When gathering our data, we selected the 5 companies' datasets from January 1st, 2000 to October 31st, 2023. These datasets included the open price, the high, the low, closing price, adjusted close price, and volume. We cleaned it by filtering out which years we wanted to select, and then by dropping all of the columns except the close variable, since that was our target. After that, we selected years from 2015 to 2018 to be our training set, and then 2019 as our test set. Ultimately, we would be predicting the stock prices for the year of 2019.
After cleaning our data, we established baseline stock predictions by using a linear regression model. These initial predictions were pretty inaccurate due to the high RMSE, and because this model doesn't typically generalize well with stock data. Because of this, we decided to switch to decision tree regression, a more complex model that should handle overfitting better than linear regression. We used the K-crossfold validation technique in order to reduce the overfitting even more. After running this process, our baseline predictions with the decision tree were much more reasonable.
After conducting the baseline, a long short-term memory model was used. Because LSTM models are a type of recurrent neural network, they have been historically excellent in predicting things such as stock market prices. Without tuning the parameters, the RMSE values for the LSTM model were pretty bad. But after fine-tuning the model, our results were much better and accurately shows how powerful LSTM models can be.
In response to these results, we retuned the hyperparameters for the 5 companies, resulting in better results. Although the RMSE was better, the predictions were still not accurate, resulting in the following graphs of predicted versus actual closing prices. As you can see, some graphs fail to capture the full extent of the stock market, resulting in major mispredictions in the Cisco and Microsoft graphs. We realized that the volatility of the market during COVID could have caused the major inaccuracies in our model. Therefore, we chose a less recent time slot instead, predicting the data from 2006 to 2011 instead.
Here are the results of our fine-tuned graphs. The results from the graphs are evident with close accuracies to the original graphs. However, when there is volatility, such that the form from the Great Recession in 2008, the predictions for some companies become inaccurate. For example, the Google and Apple stocks were inaccurate during this period of the Great Recession in 2008. Because of this, we fine-tuned our LSTM models by selecting years where the volatility was much lower, namely 1990 to 2010.
In essence, the LSTM model with fine-tuning and a different time frame demonstrates the best performance. For most stocks, this model achieves the lowest RMSE values surpassing both the decision tree baseline and other LSTM models. The findings emphasize a need for a nuanced approach, considering the characteristics of individual stocks and external factors that may influence their behavior. Future work could involve further exploration of different hyperparameters, model architectures, and additional feature engineering to continue improving predictive capabilities.
This work has been part of the Machine Learning for Virginia project at the University of Virginia.